Algebra 2, Chapter 8.1, exercises 13 through 21. This set builds upon what we went over in the last video lesson, which shows how to take cubic functions. I'm going to go back here, just take a look at a couple of those types of problems, 11 and 12, for example. In this video lesson, we're going to go ahead to work on quartic functions, which are polynomials of degree 4. And it will be factoring and putting into factored form these equations, these functions. And so what we're going to do here is set this function equal to 0 and find the zeros to find factored form. Well, to do that, we're going to use synthetic division after first using the rational zeros theorem. And to find our potential rational zeros, we take, I'm going to put potential rational zeros. To create a list, we take plus or minus factors of constant term over factors of coefficient of first term. So for this particular problem, 13, by the way, I'm going to go over these odd number problems here, work those out. And for this one, we have plus or minus factors of 12. And our factors of 12 are going to be 1, 2, 3, 4, 6, and 12. And they're going to be over 1 because the coefficient of the first term is 1. So what we have here is possibilities of plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and finally plus or minus 12. Quite a list. So we're going to go use synthetic division to test. And I recommend, unless otherwise notified, testing the smaller numbers first to make arithmetic easier. So we're going to check as a 0 x equals 1. And to do that, we're going to bring down our synthetic division bracket, and we're going to put our 0, 1 out here. And then we take our polynomial 1x to the 4th, 5x cubed, negative 1x squared, negative 17x, and plus 12. We're going to bring down the 1. And so we're going to have 1x cubed. 1 times 1 is 1. 5 plus 1 is 6. 1 times 6 is 6. Negative 1 plus 6 is 5. 1 times 5 is 5. Negative 17 plus 5 is negative 12. Negative 12 times 1 is negative 12. And so we have 0. And so, therefore, Now, x equals 1, and to find our factor, we need to subtract 1. So x minus 1 equals 0. So x minus 1 is a factor. Is a factor of our original expression up here. Next, we have x cubed plus 6x squared plus 5x minus 12. That's what we have left after our division by x minus 1, effectively. And so we're going to check again. We're going to check x equals 1 as a factor. And to do that, we just go through the same process we went through, except we're going to put 1 out here. We're going to put 1x cubed, 6x squared, 5x, and negative 12. And so bringing down the 1, then we bring down 1 times 1 is 1, 6 plus 1 is 7, 1 times 7 is 7, 5 plus 7 is 12, 1 times 12 is 12, 0. So we have x minus 1 is a factor. So what we have is we have x minus 1 as the factor twice, and left over, I'm working to the right down here, we have x squared minus plus 7x plus 12. And I'm going to write our answer. So this is a factor. X minus 1 is a factor. X minus 1 is a factor. And then factoring this quadratic trinomial below, we have factors of x squared are x and x, and we have plus, and what two numbers, when added together, equal 7, but when multiplied together equal 12? Well, that would be 3 and 4. So here would be other factors. So in factored form up here, I'm going to rewrite this as k of x is equal to quantity x minus 1 times quantity x minus 1 times quantity x plus 3 times quantity x plus 4. And this will be our factored form, which I'm boxing in here. So this is what is called, to the fourth power, it's called a quartic function or polynomial. I'm not going to work out entirely number 14, but I just want to show the viewer that here we have again a quartic function to the fourth power. We have a common factor of x. So if we factor out an x, we have x times quantity x cubed minus 6x squared plus 11x minus 6. And now the viewer can go ahead and factor what remains, this cubic polynomial. So, and continue with the factoring there. Next on our problem 15. Again, we have using our rational roots theorem, and I'm not even going to list it there. We have plus or minus factors of the constant term, which are going to be 1, 2, and 4 over 1. So we're going to have plus or minus 1, plus or minus 2, and plus or minus 4. So definitely a smaller list. We're going to go check the same way we did earlier. Is we're going to check x equals 1. Going to do that same process as before. Put 1 on the outside, and inside the coefficients, 1x to the 4th power minus 2x cubed minus 3x squared plus 4x plus 4. We bring down the 1. We have 1. 1 times 1 is 1. Negative 2 plus 1 is negative 1. 1 times negative 1 is negative 1. Negative 3 plus negative 1 is negative 4. 1 times negative 4 is negative 4. We have 4 plus negative 4 is 0. And then we have 1 times 0 is 0. And we have a remainder of 4. So we know x equals 1, not a 0. And next we're going to check x equals negative 1 as 0. Now, as I mentioned in the previous video lesson, with the synthetic divisions being required for these problems, it may make sense for you to use another supplementary sheet of paper with which to work out these exercises beyond what you're given on the worksheet that I have given you, if you are a student in my class. Okay, same process. We bring down the 1. 1 times negative 1 is negative 1. Adding negative 2 and negative 1 together, we get negative 3. Negative 1 times negative 3 is 3. We get negative 3 plus 3 is 0. Negative 1 times 0 is 0. 4 plus 0 is 4. Negative 1 times 4 is negative 4. We have 0. So we have, I'm going to write this over here, x minus 1, or put x equals negative 1, because that is a 0. If we add 1 to both sides of this equation, we get x plus 1 is equal to 0. So x plus 1 is a factor. Okay, next. We're going to check x equals negative 1 again. But this time we're going to check what we have left over, which is 1 x cubed minus 3 x squared plus 0 x plus 4. And we bring down this 1. So we have 1. Negative 1 times 1 is negative 1. Negative 3 plus negative 1 is negative 4. Negative 1 times negative 4 is 4. 0 plus 4 is 4. And negative 1 times 4 is negative 1, negative 4. And we get 0. So we have, working to the right, we have x squared minus 4x plus 4. And factoring this quadratic trinomial, we have x and x. And we have minus 4x and plus 4. So we're going to have minus 2, minus 2. So these are the factors that we have found. So we have x plus 1 is a factor here. So we have x plus 1 twice, which we got from doing synthetic division with a 0 of negative 1. So we have x plus 1 is a factor, x plus 1 is a factor, and x minus 2 and x minus 2 are our other two factors. So rewriting up here above, we have in factor form h of x is equal to quantity x plus 1 times quantity x plus 1 times quantity x minus 2 times quantity x minus 2. And that is going to be our answer to problem number 15. Okay, next, let's go to next other problem, 17. J of x equals x to the fourth power plus 3x cubed minus 12x squared minus 20x plus 48. Our potential rational zeros are going to be plus or minus. We'll have 48 over 1. We're going to go from lower numbers first. Plus or minus 1. What other factors of 48 do we have? 2, so plus or minus 2. 48, we can divide 48 by 3. So we're going to have plus or minus 3. So a lot of potential factors here. Plus or minus 4. Plus or minus 6. Plus or minus 8. Plus or minus 12. Plus or minus, is 18 going to be 1? Plus or minus 16. That's right. Okay. Plus or minus 16. And finally, plus or minus 24. And finally, plus or minus 48. So quite an extensive list. Quite an extensive list of potential rational zeros. We're going to try, we're going to check x equals 1. And to do that, come over here, like we've done earlier. Put 1 outside here. So we put in our numbers 1x to the fourth, 3x cubed minus 12, x squared minus 20x plus 48. We'll bring down our 1. 1 times 1 is 1. 3 plus 1 is 4. 1 times 4 is 4. Negative 12 plus 4 is negative 8. 1 times negative 8 is negative 8. Negative 20 plus negative 8 is negative 28. And then 1 times negative 28 is negative 28. And we're going to get, we add 48 and 28, negative 28, we're going to get 20. So we'll say not a 0. Check that. Now we're going to check x equals negative 1 as a potential 0. Do that. put negative 1 outside here, and then the inside we put the same as we did up above, 1, 3, negative 12, negative 20, 48. Same process, bring down the 1, negative 1 times 1, negative 1, negative 3 minus 1, 3 minus 1, 2, negative 1 times 2, negative 2, negative 12 plus negative 2, negative 14, negative 1 times negative 14 is 14, negative 20 plus 14 is negative 6, negative 1 times negative 6 is 6, or excuse me, yeah, is 6. Adding these two together, we get 54. So this is also not a 0. Okay, next we're going to check 2, check x equals 2. And we bring this down, put here, so we'll put 2 here, and then 1, 3, negative 12, negative 20, and 48. So bring down the 1, we get 1, 2 times 1 is 2, 3 plus 2 is 5, 2 times 5 is 10, negative 12 plus 10 is negative 2, 2 times negative 2 is negative 4, negative 20 plus negative 4 is negative 24, 2 times negative 24 is negative 48, so we end up with 0. So we have x is equal to 2, so if x is equal to 2 and we subtract 2 from both sides, we have x minus 2 equals 0. So x minus 2 is a factor. Okay, now I'm gonna come up here again. I'm going to use, in this case, we're gonna check x minus 2, or x equals 2. So check x equals 2. Erase that. We'll put check x is equal to 2. And to do that, we're going to take our 2. Again, we've already checked 1 and negative 1. So this time we're left with x cubed plus 5x squared minus 2x minus 24. So that's what we're going to use up here. So I put 1 x cubed 5x squared minus 2x minus 24. So bring down this 1. We have 1. 2 times 1 is 2. 5 plus 2 is 7. 2 times 7 is 14. Negative 2 plus 14 is 12. 2 times 12 is 24. We're left with 0. So we have x minus 2 is a factor. We use 2 again. X minus 2 is a factor. So we have those two factors. And then finally we have this x squared plus 7x plus 12. And that's going to be equal to x plus 3. That's going to be x plus 4. So these are the other remaining factors from this quadratic trinomial. So I'm going to put up here j of x is equal to quantity x minus 2, quantity x minus 2, quantity x plus 3, quantity x plus 4. So there we have that. Okay, next. On our problem 19, a company designing a new rectangular shipping box must have a volume of 24 cubic inches. The company has created a box with a width that is 2 inches less than its length. The height is 5 inches greater than the length. What are the dimensions? So we're going to say, we're going to let this length be x. That length, and a volume is equal to length times width times height. And if we say let x equal length, we have our volume is equal to x for the length, and then we have a width. It says width that is 2 inches less than its length. So width equals x minus 2. So x times quantity x minus 2. And then we have the height is 5 inches greater than the length. So height equals x plus 5. So really, that's what we have so far. But let's go ahead and work this out. Now we say that our volume is 24 cubic inches. We're going to solve for x. So we have 24 is equal to x times quantity x minus 2 times quantity x plus 5. Now we can multiply these two linear binomials together. I'm going to come over here and do a little box. We've done some of our classes. So we're going to take a 2 by 2 box. We're going to multiply x minus 2 times x plus 5. So you have x squared minus 2x. X times 5 is 5x. And then 5 times negative 2 is negative 10. So we have x squared plus 3x minus 10. And so for this, we're going to have 24 is equal to x times quantity x squared plus 3x minus 10. And then multiplying out, we have 24 is equal to x cubed plus 3x squared minus 10x. And to solve this equation, we're going to subtract 24 from both sides of it. So we have 0 is equal to x cubed plus 3x squared minus 10x minus 24. And to solve this equation, we're going to try different values. And we're going to look at the rational zeros theorem. So what are the potential zeros here? Well, if we have this factor of 24, so we'll have plus or minus 1, comma, plus or minus 2, comma, plus or minus 3, comma, plus or minus 4, comma, plus or minus 6, comma, plus or minus 8, comma, plus or minus 12, comma, plus or minus 24. Now, this video being as long as it has been already, I'm going to go straight to try 3. I'm going to check x equals 3, and we put 3 in here, and we're going to factor this cubic polynomial. We have 1x cubed, 3x squared minus 10x minus 24. Let me bring down this 1. 3 times 1 is 3. 3 plus 3 is 6. 3 times 6 is 18. Negative 10 plus 18 is 8. And 3 times 8 is 24. And we have 0. So if we have x equals 3 as a 0, we subtract 3, we have x minus 3 is equal to 0. So x minus 3 is a factor. So, and we have left, so that is a factor. And left we have x squared plus 6x plus 8. And in factored form, that's going to be x and x plus 2 and 4. Now, what that means is in factored form, this is going to be 0 is equal to x minus 3 times quantity x plus 2 times quantity x plus 4. Well, what is our answer going to be? Well, our answer is going to be L is equal to 3. Why is that? Because these other two factors would have L being negative numbers. In the first case here, this would be x is equal to negative 2 and x is equal to negative 4. So length is 4. Our width is going to be x minus 2 is going to be, so 3 minus 2 is equal to 1. And our height is going to be 3 plus 5 is equal to 8. So we have 3 times 1 times 8. So this will be our length, width, and height of our box. And I took a shortcut by not putting the 1, negative 1 and negative 1, 2 and negative 2. I went straight to 3 in interest of the length of the video, pretty much. 21, Natural History Museum is building a pyramidal glass structure for its tree snake exhibit. Its research team has designed a pyramid with a square base with a height that is 2 yards more than the side of its base. The volume of the pyramid must be 147 cubic yards. What are the dimensions? What we have is the volume of a pyramid is going to be 1/3 of its base, and the base is going to be length times width times its height. Okay, so what we have here is the volume of the pyramid is 147. So 147 is equal to 1/3, and a square base. So we could say our base is going to be just x times x times the height is 2 more, so x plus 2. So what we're going to have here is we can work this out. We can multiply by 3 to get rid of this 1/3. So multiplying this whole, multiply both sides by 3. It's 147 by 3. We get 441 is equal to x squared times quantity x plus 2, which is going to be equal to x cubed plus 2x squared. And so if we subtract 441, we have 0 is equal to x cubed plus 2x squared minus 441. Now, your factors of 441, and we have plus or minus factors of 441 over factors of 1. So our potential rational zeros are going to be plus or minus 1, plus or minus 3, plus or minus 7, plus or minus 9, plus or minus 21, plus or minus 49, plus or minus 49, plus or minus 147, and finally plus or minus 441. So a lot to work with there. What I'm going to do is recommend that the viewer go ahead and try. Again, this will be a long process. I invite the viewer to check x equals 7 as a actual rational zero. To do that, you go like this. I'm just going to stop right. So we got 7 out here. And we're going to have 1x cubed plus 2x squared plus 0x minus 441. So, yeah, 1, 0, 5, 4, 7. Yeah, I think that works out. So anyway, that's all I'm going to do in this video lesson. I hope this has been helpful to you. Good luck, and thanks for viewing.